Okay, shall we do the next concept?
Okay, sir.
Tell me what you need.
Sir, any chapter is fine.
Complex numbers. Have you complex numbers in plus 12, plus 2?
Yes, sir, but they didn't start it first.
But
They didn't start it first.
yeah. Can I start the complex numbers concept?
Okay, sir.
Complex numbers. Yeah, basically what the complex numbers, where we are using, how we can use, what is the differences between normal numbers and complex numbers. Yes, you can see, uh, of course you know very well. Once again I will tell you, we know the natural numbers, that is natural number set indication with capital N. In that set having all naturals from 1 2 3 etc. 1 2 3, the positive numbers from starting from 1 onwards in up to infinity are nothing but a natural number set. This is called natural numbers. Next are whole numbers. Whole numbers can be indication with the capital W. In that whole numbers 0 1 2 3 etc. 0 1 2 3 etc. This when the natural numbers along with the 0 are nothing but whole numbers. Whole numbers. Next, integers can be indication with capital Z. In that, Z having positive numbers, negative numbers along with the 0. That means here -3, -2, -1, 0, 1, 2, 3, etc. etc. These are all called integers. Integers. Next, rational numbers is nothing but Q. Rational numbers having P by Q form it is actually, where P comma Q both are integers. Of course, Q is not equal to 0. P and Q both are integers. Q value is not 0. Okay. So the form, this is in the form P by Q or rationals. P means a numerator, Q means a denominator. And again Q star. Q star means irrationals. This is rationals, this is irrationals. So square root of P, where P be the P is a odd number. Odd. Odd numbers means what? Even and odd. Which numbers are divisible with the 2, that is even, not divisible with the 2 is odd numbers. Square root of odd numbers, root 3, root 5, root 7, and except root 9. 9 is an odd number, but not root 9 is not an irrational. Root 9 value is 3, that 3 is rational number. Yes, root 11 also rationals. Root 17, root 19, root 21, and root 23, etc. These are all numbers are nothing but a Q star. Q star means what? Irrational numbers, rational and irrationals. Yes, you see that here you can observe here. Natural number set is subset to whole numbers subset to integers subset to rationals, rational subset to irrationals. Of course, irrationals is also subset to real numbers. So real numbers it is capital R. R having all naturals, whole numbers, and integers, irrational, etc. etc. Now the complex number set, that is capital C. Complex numbers. The complex numbers having two form. The number is in the form a plus ib. A plus ib, where here a comma b are real numbers, whatever it may be. A means a real part, B means a imaginary part. This is a real part and a imaginary part. A plus IB is called a complex number. Yes, when we are taking that complex number, C equals to, yeah, C equals to R by R, real numbers to real numbers, which are having an ordered pair A comma B, such that A comma B both are real numbers, where A is called a real part, B is called a imaginary part. So I be the imaginary symbol and I square value is -1. Complex number symbolically we are writing I square. Yeah, I means when we are writing square root of negative values where we can have, then that time we are using I. That means suppose root 25 is nothing but actually 5. But what about the root over -25? Yes, this kind of the root over 25 into I square. So square root of 5i whole square. So then root and square both will cancel, then we are getting 5i. So root 25 value is 5i. Root -25. So surds and radicals, radical having negative symbol, then the negative will be converted into the imaginary, that imaginary part. Okay, that's enough. Suppose we are taking z, let it be take z equals to a plus ib, a plus ib and a comma b both are real numbers. Yeah, for example, z equals to 5 plus 6i, 5 and 6 both are real numbers. Yes, what we are taking in imaginary and real parts. Okay, suppose the equality of two complex numbers, if z1 equals to a1 plus ib1 and z2 equals to a2 plus ib2, a2 plus ib2. Okay, if real parts are equal, a1 equals to a2 and imaginary parts also equal, b1 equals to b2, then z1 equals to z2. Real parts and imaginary parts are equal, then the complex numbers are equal. If the complex numbers are equal, the real number, a real part and the imaginary parts also equal. That's enough. Next, how we are taking the complex addition, addition of two complex numbers. Suppose if z1 equals to a1 plus ib1 and z2 equals to a2 plus ib2. Taking addition of two complex numbers is z1 plus z2 is a1 plus ib1. Here this is ib1 plus a2 plus ib2. When we are adding two complex numbers, then the corresponding parts will be added. Corresponding parts means real part and imaginary part. That is a1 plus a2 plus I into b1 plus b2. Here a1 plus a2 is real part, b1 plus b2 is also imaginary part. For example is z1 equals to 5 minus 6i and z2 equals to 7 plus 8i. Now z1 plus z2 is nothing but 5 minus 6i plus 7 plus 8i. So 5 plus 7 will be take 12 plus minus 6i plus 8i. So it is plus 2i. So 12 plus 2i. Yeah, this is also a complex number. When suppose complex numbers addition it satisfies the commutative property. Z1 plus Z2 equals to Z2 plus Z2. Z2 plus Z1. That is a commutative property, associative property, inverse and identity. All properties are satisfied. Next, if Z1 equals to A1 plus IB1, Z2 equals to A2 plus IB2. A2 plus IB2. Then multiple with these two, Z1 into Z2. Z1 into Z2 is now you see here A1 plus I into B1 into A2 plus I into B2. Just we can multiple with A1 into A2, A1 A2 plus A1 into IB2, I A1 B2 plus IB1 into A2, I B1 A2 plus I into I square B1 B2. Already I told you that I square value is minus 1. Just we substitute here I square value minus 1 here. A1 A2 minus B1 B2. This is one real part. Imaginary part is I into A1 B2 plus B1 A2. This is real part, this is imaginary part. Matrix multiplication, sorry, not matrix, complex numbers multiplication is also a complex number. Okay, complex numbers multiplication is also a complex number. That's enough. Here, complex additive inverse. Additive identity means z plus 0 equals to 0 plus z equals to z. 0 be the additive identity. Additive identity. Next, z plus of minus z plus z equal to 0. This is called additive inverse. Additive inverse. These two are important for respect to the additive. And for multiplication wise is z1 into 1 equals to 1 into z1 equals to z1. One is called multiplicative identity of complex numbers, as well as z into 1 by z, or and z 1 by z into z equals to 1. So it is multiplicative inverse, multiplicative identity. Multiplicative inverse and the multiplicative identity we got. Yeah, suppose here a complex number 0 is nothing but 0 into 0 plus 0 into I. This is also noted as 0 comma 0, real part and the imaginary part. Yes, 0 is always a real part, 0 is always a imaginary part. Suppose 1 is nothing but write 1 plus 0 into I. That means 1 comma 0. 1 comma 0. Next, a conjugate complex number. If z equals to a plus ib, then conjugate complex number denoted by z bar equals to a minus ib is conjugate complex number. Z z bar is the conjugate complex number. Now, that's enough. Now, the rationalization of a complex number is If Z equals to A1 plus IB1 is there by A2 plus IB2. How we are writing this into a complex number? So yes, it is a complex number. Of course, fraction is there, numerator and denominator. At that time, you have to take the rationalization of denominator into A2 minus IB2 divided by A2 minus IB2. Okay, this into this into this. When we need to take the rationalization of a fractional complex number, we will take the conjugate of denominator, we will multiple and division with the same, A2 minus IB2. Now we multiple here A1, A2, A1, A2 minus I into A1, B2, next plus I into A2, B1, plus of minus minus I square B1, B2 divided by the same A2 plus IB2, A2 minus IB2, A plus B into A minus B, A square minus B square. In the same way, A2 square minus IB2 whole square. When we are writing I square value is minus 1. Yeah, Aditi. Good evening, Aditi. You are not attending the properly. Yes, of course, your choice. Yeah.
Sir, actually, I was outside. I just came back home.
What?
I was outside. I just came back home.
Yeah, now we substitute I square equals to minus 1 here. Minus of minus, it is plus. Now A1, A2 plus B1, B2. Okay. Plus I is taking common here. I is taking common A2, B1 minus A1, B2. Divided by A2 square minus I square B2 square. Here. I square means minus. Then we'll take minus of minus plus. Yeah, A1, A2 plus B1, B2 divided by A2 square plus B2 square plus I into A2 B1 minus A1 B2 divided by A2 square plus B2 square. Okay, this is the real part, this is the imaginary part. So the rational number of a complex number is also a complex number. For example wise also we will see. For example is example, yeah, 5 plus 6i by 2 minus 3i. How we are calculating this? Here this one 2 plus 3i. The conjugate is 2 minus 3i, conjugate is 2 plus 3i. Multiple and division with 2 plus 3i. Then we are getting 5 plus 6i into 2 plus 3i divided by 2 minus 3i into 2 plus 3i. 5 2s are 10 here, 10 plus 15i plus 12i plus 18i square divided by 2 square minus 3i whole square. I square value is minus 1, we are substitute. I square value minus 1, 10 minus 18, 10 minus 18 plus 15 plus 12, 27i by 4 minus 9i square. So this is minus 8 plus 27i by I square value minus 1 minus of minus plus 4 plus 9 is 13. So that minus 8 by 13 plus 27 by 13 into I. This is a complex number. That's enough. Next, integral parts of complex numbers. Integral parts means what? Integral parts means I square value is minus 1. I cube value is I square into I. Then it is a minus I. And I to the power of 4 is I square whole square. So minus 1 whole square. Then it is plus 1. Next, I to the power of 10 suppose. This is I square, I power 10. I square into I power 8. So I square into I square whole power 4. Or I square power 5 also we can write. So it is minus 1 into minus 1 power 4. Yeah, minus 1. This kind of we will take I power 4 also we can write 1. And so on we can write. Next, conjugate complex numbers, properties of conjugate complex numbers. The conjugate of Z is Z bar. If Z1 comma Z2 belongs to C, both are complex numbers, then the first one is Z1 plus Z2 whole bar. That is Z1 bar plus Z2 bar, and Z1 minus Z2 whole bar is Z1 bar minus Z2 bar. This means conjugate complex numbers. And next, Z1 Z2 whole bar. Individually, we can take Z1 bar into Z2 bar, and Z1 by Z2 whole bar is Z1 bar by Z2 bar, Z1 bar by Z2 bar. These are all properties of conjugate complex numbers. Next, modulus. Modulus means what? If Z equals to A plus IB, Z equals to A plus IB is a complex number, which is a complex number. Then the non-negative real number. Then the non-negative real number, square root of A square plus B square. A square plus B square is called modulus of Z. Modulus of Z. It is denoted by mod Z or smaller. Yeah. Basically here the modulus of a complex number means that the distance from the origin to the complex number. Origin is 0, 0, complex number is A comma B. So square root of A minus 0 whole square plus B minus 0 whole square, then square root of A square plus B square. Then it is the distance from origin to a complex number in a complex plane or organ plane, whatever it is. Okay. So generally the modulus nothing but Z equals to A plus IB. If Z equals to A plus IB, then the mod Z equals to modulus of A plus IB. This can be write as square root of A square plus B square. For example wise, Z equals to 2 minus 3i is there. then mod z equals to modulus of 2 minus 3i. So this is square root of 2 square plus 3 square plus of minus 3 whole square. Yeah, square root of 4 plus 9. Yeah, 9, 13. Square root of 13 is that answer. Square root of 13. If mod z value is 0, then z value is 0. Z value is 0. And some properties we have the modulus. You see, modulus of z1 plus z2 is less than or equals to mod z1 plus mod z2 individuals. Mod z1 plus mod z2. Modulus of z1 minus z2 is, of course, modulus of z1 plus z2. Modulus of z1 plus modulus of z2. And modulus of z1 minus z2 is norm of mod z1 minus z2. Okay. Next, modulus of z1 into z2 is mod z1 into mod z2 and division mod z1 by z2 is nothing but modulus of z1 by modulus of z2. Z2 if z2 is not equal to 0, the mod z2. Mod z2 compulsory not 0, of course it is. That's it. And we are writing the sum of the values here. Square root of I, how we are writing? Square root of I means this is equals to plus or minus 1 by root 2 plus I into 1 by root 2. This is the formula or notation for root I. Yes, there will be a proof by using the polar form. Polar form of a complex number, one topic we have. In that polar form, we have the proof of root or square root of I value, how we are writing plus or minus 1 by root 2 plus I by root 2. Next, nth root of unity. Nth root, let n be a positive integer. Let n be a positive integer. Z be a complex number. Z be a complex number. Then the solution of of x to the power of n equals to z are called nth roots of z. Nth roots of z. Suppose n equals to 3, that is cube roots of z. Okay, the nth roots of z are called cube roots of z. Cube roots of z. How the cube roots of z we have? The cube roots of unity are the cube roots of unity are 1 omega omega square. 1 omega omega square. Here the omega values we have omega equals to 1 minus 1 plus root 3 I by 2 And omega square also -1 minus root 3 I by 2. And sum of all the cube roots are 0. 1 plus omega square is 0. And 1 into omega square, that is omega cube, equals to 1. That means omega equals to cube root of 1, cube root of unity. That means 1 power 1 by 3. And next, the product of the cube roots of unity is also 1. That means 1 into omega square. 1 omega square are in GP. GP means geometric progression. That's it. Okay, Chandra and Aditi, most of the time we spend. Some more concept we have. In the next class we will discuss. Okay, Aditi and
Okay, sir.
Okay,
Sir,
sir.
can you send the notes?
yeah, I will send.
Thank you, sir. Good night.
Okay, sir. Thank you.